Okay, so this week we're going to go through trigonometric integrals. This will be the third integration technique for the semester. So there's a few more to go, and then all of that will be for class test 1. Okay, so just make a note for class test 1. It will be these integration techniques. So U substitution, integration by parts, trigonometric integration, trig substitution, partial fractions. Right, that list that we went through at the beginning. Okay, so all of that will be for class test 1. And then class test 2 will be everything else after that. Okay, for the second part of the semester. Okay, which means, again, class test 1 is just all calculations, right? So like we did in the tutorial and the tutorial assignment and the quizzes, just those calculations, that will be all class test 1. Okay, no proofs or anything, just straight calculations. Any questions on that? You're all good. Okay. So, trigonometric integrals. Yeah. So the next section that we're doing is trigonometric substitution. So please don't mix up the names when you're looking in the textbook or Googling things. So this one is going to be trig integrals. So these are integrals that just contain trig functions. So it will be sine, cos, tan, sec, cotan, all of those. That will be this section. Then the next section is trigonometric substitution. Very different stuff. Okay. So they'll be related, but just don't mix them up when you're looking in the textbook. So we'll start off with a very simple example, just to get the idea of how to solve these. And then there are 4 rules that we need to learn. Okay, so there's just 4 things that we need to know, and then that will cover all of the different cases. Okay, so let's start off with example 1. So we have the integral of cos to the 3x dx. Okay, so cos cubed. Now, what we want to do is try and rework this into a U substitution problem. Okay, so that's the idea for all of these. We're given some trig integral with some trig function there. We want to rewrite it using our trig identities into something we can do with a U substitution. So the idea: use trig identities to rewrite this as a U subproblem. Okay, that's the whole idea for this. So we've got this trig function, cos cubed. We want to rewrite it in such a way that we can do a U substitution. Okay, so I'll show you what to do for this first one, and then we'll try to work out what the pattern is. Okay, so this is going to be equal to cos squared x times cos x dx. So we see we've got cos cubed. I took out a factor of cos x. So it's cos squared and then cos x next to it. Okay, so that's the first step we're going to do. Now, some of you might see where this is going. The cos squared, we can use a trig identity to rewrite that in terms of sine. Yeah. So cos squared, how can we write that as sine? 1 minus sine squared. Yeah. Okay. So we've rewritten it a little bit. Now here we can do a U substitution. So look at the first part, 1 minus sine squared. If we let U be sine x, what do we get for du? Cos x. Okay, so that takes care of that there. So again, the idea is to let U be that sine x that we have. So du will be cos x, which we have on the end there. And now this is just a U substitution, right? Which we've covered previously. So this will become the integral 1 minus u squared, okay, for the first part. And then cos x dx, that's just du. Yeah. Now, all of the trig stuff is gone. It's just a normal u sub problem with power rule. So we can integrate this. So this will be u minus 1/3 u cubed plus c. And then once we've done that, we can put the trig function back. In this case, it's going to be sine. So this is going to be sine x minus 1/3 sine cubed x plus c. Okay. Does everyone see what we did there? So we used some trig identity to rewrite this in such a way we could do a u substitution. Then we'll say u equals sine, so du is cos, and then it's just the normal power rule after that. Okay, so it's okay if you don't see it for this example. We'll do one more, and then we'll look at the general rule. Okay, so example 2, we have the integral of sine to the 5x cos squared x dx. Okay. So between the sine to the 5x, so that's a 5. So between the sine to the 5x and the cos squared x, which one makes more sense to pull out as a factor? The sine or the cos? The sine. Okay, good. You're catching on. So we can take out the sine x and then leave the rest on the side. So let's do that. So the first one, that will be sine to the 4. Now notice we took out a sine and we left with a mix of sine and cos. So what should we change that first part to so that the du becomes sine? Oh, someone said it? So we've got sine to the 4 and cos squared. Should we write it in terms of sine or should we write it in terms of cos? Hands up if you say we write it in terms of sine. A few. Who says we should write it in terms of cos? Few, okay. And then the others, you're going to skip class test 1. Okay. No, we're going to write it in terms of cos. Because if we let u be cos, what's du going to be? It's going to end up being the sine on the side there. Like we had over here in the previous example, we changed it to sine because du was cos. You see how it's the other way around now? Okay, so here, if we change everything to cos, we can let u be cos, and then du, that will take care of the sine. Does everyone see that? Okay, so let's change all of that front stuff to cos. So here we can write this as the integral of sine squared squared. Okay, that's just sine to the 4. But now we can use our trig identity with the sine squared. Then we have cos squared and sine x on the outside. Okay, so we still want to change it to cos. So how can we go from sine squared to something with cos? 1 minus cos squared. Yeah, we can put that in the brackets. So this will be the integral 1 minus cos squared, still squared. And then we have cos squared on the outside. And we still have the sine x on the outside there. Now, if we let u be cos, and then du, that will take care of the sine. So we're going to have u equals cos x. What's the derivative of cos? Minus sine. Good. Okay, now we don't have a minus there, so let's just take it over to the other side. Okay, now we have everything we need to substitute. So wherever we see a cos, we're going to put the u, and then at the end there, the sine x dx, that's going to become minus du. So this will be 1 minus u squared squared, another u squared, and then a minus du. Okay. Now, once we expand everything out, it's just normal power rule. So first, let's take the minus to the front. Okay. Then the square, let's expand that out. So it will be 1 minus 2 u squared plus u to the 4, u squared still on the outside. Then we distribute inside. So this will be minus the integral u squared minus 2u to the 4 plus u to the 6. Okay, once that's done, just normal power rule, then we're done. So this will be minus 1/3 u cubed minus 2 over 5 u to the 5 plus 1 over 7 u to the 7. Okay, so all of the integrations done, problem solved. Now we just put the cos x back inside for u. So this will be minus 1/3 cos cubed x minus 2 over 5 cos to the 5 plus 1 over 7 cos to the 7. Okay, here we're done. Any questions for this one? Okay, so you should get the idea from part 1 and part 2. Let's have a look at the rules. Okay, so these were 2 specific cases, but these rules will allow you to look at it case by case to see what needs to be done. So rule number 1, if the power of cosine is odd, okay, then there's a couple steps. Factor out a cos. Cos x. Then change the rest of your expression to sine. And finally, let u be sine x. Okay, so that's a general rule that we can use if cos is an odd power. So let's go back to the first problem and see what we did. So here we had cos cubed, that was odd. Remember, step 1 is to factor out a cos. That's what we did there on that first line. Then step 2, change everything else to sine, which we did in the next line using the trig identity. Okay, 1 minus sine squared. And finally, the last step was let u be sine, which we did on the right there. So u was sine, and then everything becomes a lot easier to do. Did everyone see that? The 3 steps? Okay. So that is if cos is an odd power. Then the next one is if sine is an odd power. Okay, which is what we had here in this example 2. We see sine is odd, so we do this rule number 2 now. Okay, so now if sine is odd, then we can follow these steps. Yeah, and the steps is exactly what we discussed before. So here we had an odd power of sine, so we took a factor of sine out, so that will be step 1. And then we used that trig identity to change everything else to cos, so that will be our step 2. Okay. And then finally, what we did on that right there, we said u was cos, so that's the last step. So those are the two rules for if the power of cos is odd and if the power of sine is odd. Okay, you follow those steps there. Okay, and then number 3, if both powers are even, Yeah. So if both are even, we can use two trig identities to rewrite them. So if we have an even power, we can write it as sine squared. Or if it's sine to the 4, that's also even, we can write it as sine squared again. So whatever even power you have, you can write it in terms of sine squared. Then we use the following identity. So 1/2, 1 minus cos 2x. Okay, we used this a little bit last year. Do you remember this one? Yeah. And then if cos is even, we can write it as cos squared, and that will be 1/2, 1 plus. So the sine squared comes with the minus, the cos squared, that comes with the plus. Yeah. And then for number 4, but we're not going to write it down, if both powers are odd, then you can pick either 1 or 2. They both work. Yeah. So if both of them are odd, you can either follow number 1 and treat cos as odd and follow those steps, or you can treat the sine as odd and follow number 2. Yeah, you'll get the same thing. So I'll leave that as a little homework exercise. So the integral of sine cubed cos cubed. So both are odd. So for homework, you're going to follow number 1. You're going to see cos is odd and follow those steps. And then you're going to do the same thing with number 2, where sine is odd, and then you're going to follow that. Okay, so homework. Use rules 1 and 2. Okay, so for the first one, you treat one as odd. Second one, you treat the other as odd. So that's the first part. And then the second part, show you get the same answer. Trig identities. Okay, so you treat it as a trig problem. So you get your answer for number 1, answer for number 2. They'll look different, but you can use trig identities to show that they are actually the same. Okay, so part 1, part 2, please do that for homework and expect something like that for the test. Hint, hint. Okay, any questions for the homework? You're good? Please do the homework. Don't think it's a surprise when you see it in the test. No, I didn't say anything. Okay. Next one. Example 4. Number 3. Integral sine squared. So here we see that the power is even. So we have an even power, so we can use this number 3 here. Okay, we've got an even power of sine. So if it's an even power of sine, we write it in terms of cos using that double angle formula. And then we can integrate that right-hand side very easily. So let's do that. So here, sine has an even power. Okay, we know what to do. We use that double angle. So this is going to be 1/2 integral 1 minus cos 2x. So this will be 1/2 x minus 1/2 sine 2x plus c. Okay, very easy, straightforward stuff. Any questions for number 3? Okay, pretty straightforward example. Okay, number 4 is a little bit more difficult. So this is sine to the 4. So it's still even, but now it's a little bit more complicated because this is sine squared squared. Yeah. So like I said, sine to the 4, we can write that as sine squared squared. So let's do that. Now, inside the bracket, we have sine squared. We can use that double angle formula. So this is going to be the integral 1/2 1 minus cos 2x squared. Okay, so half squared, that's a quarter. We can take that out. And then expanding the inside, so we're going to have a 1 minus 2 cos 2x plus cos squared 4x. Okay, now we have a problem where cos has an even power. Okay, remember what I said with all these problems being mixed? Okay, so you have different things you have to do in a single problem. Like we had that example with the u substitution and integration by parts. Here we have a problem where sine has an even power, and then halfway through, now you have a similar problem, but with cos having an even power. Okay, again, all of the stuff is mixed. So now we have cos with an even power. Yeah, but that's fine. We know what to do with cos. Let's go back up a bit. So cos squared, we can write as 1/2 1 plus cos 2x. So we can fill that in. So this will be 1/4 integral 1 minus 2 cos 2x plus 1/2 1 plus cos 8x. Remember, it doubles. So 4, that doubles to 8 now. Okay. Then we can expand everything out and do the integral. Okay, so we have 1. Yeah. Okay, sure. So we have 1 plus the half from the bracket there. So that's going to be. You can't be that sleepy. 1 plus a half. 3/2. Okay, thank you. Just checking you haven't fallen asleep yet. Then we have minus 2 cos 2x. Okay, and then the half and the cos 8x we can put at the end. Okay, so everything's written out nicely. We can just do the integration and then we're done. So this will be 1/4 3/2x minus the cos becomes sine, and then the 2 we need to divide by that. So this will be minus sine 2x plus, and then the cos 8x comes sine 8x, and we divide by the 8. Okay. Everyone clear with this example? No? Who said no? You said no, so I thought it coming from there. Okay, so here we're using cos squared theta is 1/2 1 plus cos 2 theta. Right, you know the double angle? So in the previous line in the pink there, we have 4x. So we double that and we get 8. So the cos squared 4x becomes 1/2 1 plus cos 2 times 4x. We get 8. Okay. So this 8 here, that is this doubling we got there. Okay. Anything else before we move on? All good. Okay. Next, we're going to look at sec and tan. So these are problems with sine and cos. We got the rules. Now we're going to look at what happens when we have sec and tan in the problem. Okay, so number 5, we have the integral of tan to the 6x sec to the 4x dx. Okay. Now remember your derivatives with tan and sec and so on. Okay, so if I have tan and I do the derivative of tan, what do I get? Sec squared. Okay, good. So if I've got tan to the 6 and sec to the 4, what should I factor out that will become du? We should factor out tan. No. Remember, we're factoring out something that will become our du. So if u is tan, du will be sec squared. So again, between the tan and the sec, what should we factor out? Sec squared. Good. Okay, so this is going to be equal to tan to the 6x sec squared, and we're going to factor out a sec squared x dx, because we want that part to be du. So we're going to say u equals tan. Why? Because du is sec squared. So that's what we take out. Okay. So that means everything in the front here needs to be written in terms of tan. So tan to the 6, that's fine. Sec squared, that's not fine. We want to write that in terms of tan. So what can we use? Sorry? 1 plus tan squared. Everyone agree? Everyone know where that identity comes from? Okay, 1 plus tan squared. So this will be the integral tan to the 6, 1 plus tan squared, sec squared x dx. So we can see on the one side, that's going to become our u part, and then the sec squared dx, that will be our du part. So let's substitute. So tan to the 6, that will be u to the 6. 1 plus tan squared, that will be 1 plus u squared. And then sec squared x dx, that will be our du. Okay, we can distribute u to the 6 inside. So that will be u to the 6 plus u to the 8. Okay, so very easy. 1 over 7 u to the 7. And 1 over 9 u to the 9. Okay, and remember u was tan, so we can just put that back, and then we're done. Okay, is everyone okay with this problem? Okay, so the idea is here we had even powers. Okay, so tan was even, sec was even. So since the sec was even, we could factor out a sec squared. And then u is tan. Now let's look at this other one. This is the other case. And then we'll look at the rules. So we have the integral tan to the 5 and sec to the 7. Okay, so now both of these are odd. Okay, so we can't take out an even power of sec. We're going to have to factor something else out. Now, in the previous one, I asked you the derivative of tan. Now let's look at the derivative of sec instead. Okay, so what is the derivative of sec? Sec tan. So now we have odd powers of sec and tan. What happens if I take out a factor of sec tan? What happens to the powers? They become even. Yeah, and then we can use the trig identity. So in this case, when both of the powers are odd, we're going to factor out a sec tan. That now makes the powers even, and then we can use the identity. Everyone see that? Yeah. So just a note, these are both odd powers. Okay, so if they're both odd, okay, we can take out a sec and a tan. So tan, that will become even now. So this will be tan to the 4. And this will become sec to the 6. And we took out sec x tan x. And again, I said the derivative of sec. So u is going to be sec. And du, that will be sec x tan x, which we factored out here. Okay, so since we're saying u equals sec, all of the stuff in front here, that must be written in terms of sec. Okay, so the tan, we need to rewrite as sec. How can we do that? Well, it's tan to the 4. We can't do anything yet, but we can write that as tan squared again. And again, this part here, that's our sec x tan x. Okay, so we still want that tan squared to become something with sec squared. So how can we rewrite it? One minus sec squared. Right? Everyone agree? Sure. So we have everything we need now. So all of that stuff in the front, we can write in terms of u, and the sec x tan x on the end there, we can write as du. Okay, and then very simple from here. Okay, so let's expand that out. Okay, then we can put the u to the 6 inside. Okay, so that's 8 there. Yeah, so now we can just use the power rule. So we have 1 over 7 u to the 7, 2 over 9 u to the 9, 1 over 11 u to the 11. Yeah. Everyone okay with that? Yeah. And then again, we said u was sec, so we can put that in, and then we're done. Yeah. Pretty easy. Any questions on these two problems before we go to the rules? All good. Yeah. So rules. Yeah, there's too much talking going on. What is it? So? Something's funny.
Last time we didn't do that across the 7. We did it across the 8, we did it electoral,
You didn't learn his lesson the last time. Okay. Rules. So number 1, let's look at this first case. So here we had the even powers, and we could factor out a sec squared. Is this the email? Ugh. Okay. So for the even powers, we could take out sec squared. So let's do that. So rule number 1. Power of sec is even. Okay, so what did we do? We took out a sec squared, we changed everything else to tan, and we said u equals tan. So factor out a sec squared. Change everything else to tan. And finally, we say u equals tan. Why? Well, because if u equals tan, then du is sec squared. So it matches up. And then the last one, this was if it was odd in both cases, so we could take out a sec x tan x. Okay, so both are odd. Then in that case, we can take out a sec x tan x. Okay, and if we take out sec x tan x, we need to change everything else to sec. Okay, and if everything else is sec, we let u be sec. So very easy. Okay, and then if u is sec x, then du is sec x tan x, which we factored out in the first step. Okay, any questions about the sec and tan type problems? You're all good. Okay. Now we've got two more examples, a little bit more difficult. So these two aren't straightforward, factor out and then change and then solve. You have to do a little bit more thinking, but not too bad. So remember, okay, so we covered this last year. It should be in your table of integrals. So the integral of tan x. So this isn't tan x with sec x. It's not like a mixed one we had before. It's just tan by itself. So we did this last time. Anyone remember? Check your books from last year. So remember, end of last year, I said, keep your books. We're just carrying on with the work. This is why. Okay, because we need to refer to these things. So integral of tan, what was that? Log of sec. Good. Okay. So this was a special one we did last year. Please rewrite it here if you don't have that table with you. And then the other one. So this is tan by itself, not mixed like the previous one. And the next one is if we have sec by itself. What's this one? It was the one we did with the 1 over cos. Yeah. Okay, good. So someone has their table with them. Okay, please remember to rewrite that table if you don't have it. Okay, because with this section and the next one, you're going to be looking back a lot. Okay, what is the integral of tan, the integral of sec, integral of cotan, cosec, all of those you need to have with you. Okay, so please, if you do not have these, rewrite them and put a box around. Okay, and then for homework, fill in the other part, the one with cotan and cosec. Okay, so tan and sec we're going to need for these problems. Cotan and cosec, you're going to need that for the tutorials. Okay, so this is next problem, so number 1. So these are the more difficult problems than what we had before. So here we have the integral of tan cubed. Okay. Now this is a trig integral, right? It's just tan here. But it's not tan and sec being mixed like we had before. Because remember here, if we look at these problems, this is when we had odd powers, but sec was included. We needed that sec there to factor out the sec x tan x. Over here, for this problem, there is no sec. We can't factor out sec x tan x. Okay, so we need to do something else. So what we're going to do is rewrite this slightly. So I'm going to split this into tan and tan squared. Okay. Now the tan squared I can rewrite in terms of sec. Then I can distribute. Okay. And then when I distribute, I'm going to do it as 2 separate problems. So the first one will be tan and sec squared as one problem, and then tan x by itself, I'm going to do as another problem. Okay. So we've got 2 problems here instead of the 1 problem up there. Okay, quick reminder, what is the derivative of tan? Sec squared. So for the first problem, if I let u be tan, what does that integral become? U du. So what's the integral? Half u squared. And then we put the tan back, it becomes half tan squared. Okay, so I'm just going to put a little star here. So this is going to be, sorry. Okay, so for this one, we notice that if we let u be tan, du becomes sec squared, and then it becomes half u squared, and then we substitute it. That whole u substitution step we did in our heads, right? From now on, those easy u substitutions, that needs to be done in your head. Okay, I don't want to see that writing out anymore. Okay, so if it's something like this, where we have tan sec squared, and the u substitution is just writing it as u du, please don't waste your time writing it on the side. Okay, you do that in your head. Okay, because when it comes to the exam, that time it takes you to write all that stuff on the side is wasted time. You should be using that for other problems. Okay, so please just put a little star there and then write u sub in your head. Okay, you need to start doing more of the stuff in your head, less time writing it out, because again, when that exam comes, the whole 3 hours you have fixed. You can't go over 3 hours. So if you're going to spend, even, extra minutes or so doing the u sub on paper, rather save it for something more difficult. Okay. So, you don't have to do it right now, but, as we go through the year, you should be more comfortable doing these quickly in your head. Okay. It's just a matter of saving time later on. Okay. So you don't get more anxious for the more difficult problems. Okay. So it's just a note there. And then the one with tan, we know that already. That's just the natural log of sec. So we can fill it in. Okay. And again, we know this one, integral of tan. We did it last year. Please don't do the working on the side. We've done all that working. Just put the answer down. Okay. Right, last year, I gave you the test with the integral of tan. You did the u substitution, all of that. We don't need to do all of that again. If you know the answer is the natural log of sec, just write it down. Okay. Saves you a lot of time. Any questions for this one? All good. Okay. And then number 2, for the slightly more difficult one, this is the integral of sec cubed. Okay. And again, it's a trig integral. Sec has an odd power there, but it's not sec tan, right? So previously, again, if we go back up a bit here sec was odd, but we cannot take out a factor of sec x tan x. We only have sec, which means we need to do something else. So like we did for tan, I'm going to split it as sec x and sec squared. Okay, very similar to what we had before. Now, at this stage, there's a few things you can do. I'm going to show you one method. You can use other methods if you want. I'm going to do this with integration by parts. It's just one of the ways. There's many ways. But let's do it with by parts. So I'm going to let u be sec. Why? Because we know the derivative of sec, right? And then I'm going to let dv be sec squared because we know the integral of sec squared. What's the integral? Tan. Yeah, so we know the answers already. So let's do integration by parts. Okay, so that's for the u part. And then the dv, that will be sec squared because we can integrate that. Like you said, that's going to be tan. Okay, so let's put all this together. So this will be the integral of u dv. That's the sec cubed we were looking for. this will be u times v, so sec x tan x, minus the integral of v du. So that will be sec and tan squared. Okay. Now we've got another problem over there with the sec and the tan. Now you might be tempted to factor out a sec tan, okay, but that's not going to help us here. Okay, think about why that doesn't work. So here, sec tan. If we try to factor out a sec tan, why doesn't it work? Let's go to the rules here. Okay, there. Why doesn't it work? We've got sec x tan squared. Sorry? Yeah. Let's check there. It says there, power of sec and tan are odd. What we've got is, what do we have here? Sec tan is even. You can't use the rule. It doesn't work, right? Both must be odd. So don't just look at something and see, oh, sec tan, I'm going to factor out sec tan. Look at the rules carefully. Both of the powers must be odd for it to work. In this case, one is even, one is odd. It doesn't work. Don't try it. Okay, so instead, this tan squared, we're going to write as sec squared x minus 1. Okay, using our trig identity. So let's rewrite everything with that substitution. So we're going to have sec cubed. So this will be sec x tan x minus the integral sec x sec squared x minus 1. Okay, so I'll just put in brackets there. That's to replace the tan squared. Next, we can distribute the sec inside. So we're going to have the integral of sec cubed is going to be sec x tan x minus the integral sec and sec squared. That will be sec cubed. Notice that we have the same thing on both sides there. Okay, we've got sec cubed and sec cubed. And then finally, we've got sec with the minus 1. So that will be minus sec. And another minus, so that will be a plus. Okay. Now we're going to do 2 steps in 1. So both of those blue terms, I'm going to take over to one side. So we've got 2 of them. The sec x tan x, I'm going to leave there. Plus, and then the integral of sec, we know that one already. Yeah. Perfect. Okay. But we still have this 2 in front, so let's put the half on the other side. We're done. Okay, so again, please note that most of the time we can use those rules from before, but if you can't use those rules, like in this problem here, so this problem here where it's cubed and you can't take out a sec tan, we need to do something else. So you need to look for u substitution, you need to look for integration by parts. Okay. So if you can't do it like a trig integral with the rules, you have to go back and look at your other methods. Yeah, in this case, we used integration by parts for it. Okay, so again, please keep in mind for all of these problems, the integration techniques are mixed. Okay, so you have one problem, it looks like a trig integral, you started, and it ends up being integration by parts. And then you go further down, and then you end up with On the right there, you end up with another trig integral. Okay, all of it's mixed up together. Okay, it can be very confusing as you go through it, but please just remember your techniques. Any questions for these two? Okay. So for the class test difficulty level, you need to think about having 3 of these types of problems where you just follow the rules. Okay. So it will be just like a sine to the 4, for example. You just follow the rules. Sine is even, you just follow the steps. So you'll have like 3 of those types of problems. And then you'll have 2 of these types of problems. Where you don't follow the rules, you have to try something else. Okay, that will be the rough weighting and difficulty. So 3 where you just follow the rules, 2 extra problems where it's not clear what the rules are. Does everyone understand that? Okay, so expect something like that for that class test 1. So it'll be 3 and 2, something like that. Okay, any questions before we move on? All good. Okay, so for the next part, we're still on trig integrals, but these look a little bit different. So these are, there's 3 types we're going to look at. So it's the integral of sine ax sine bx dx. So it's not powers of the trig functions. Here we change, like the frequency of the wave kind of thing. So it will be sine ax sine bx, no powers. So that's type 1. Type 2, integral of cos ax cos bx. That's type 2. So type 1, both are sine. Type 2, both are cos. You can guess what 3 is going to be. Sine and cos, yeah. Okay. So again, it's not powers of sine and cos, but they look something like this. Okay, so how do we go about solving this? So remember your sum angle formulas. Oh, well, sum difference angle formulas. You remember those? The sine a plus b, cos a plus b, those ones. You remember them? Okay, if you don't, please write them out here. Okay, so the first one, let's say sine a plus b. Anyone remember this? So we can write it out. I'll start you out and then we have to go through it. So it will be sine a times cos b, good. And then plus or minus, plus, good. And then what do we do with the a and the b? Yeah, we just swap them. Good. Yeah, so we swap them around. Okay, good. Then there's another one, sine a minus b. What's that going to be? Sine a, yeah. And then we have? No, not sine. Cos b, good. Then plus or minus? Minus, yeah. Sine b cos a. Okay, we got through that. Then the other one, that's with cos. So again, please write these out if you don't know them. Will be very important in a bit. So let's look at the one where we add them. What's that going to be? Cos A, cos B, yeah. Minus, yeah, sine A, sine B. Okay, good. And then last one, cos A minus B. So this is going to be cos A, cos B, and now there's a plus. Okay, everyone clear on this? Okay. Again, if you don't have them, please write it down, put a big box around it so you can see it clearly. Okay, now I'm going to label these equations 1, 2, 3, and 4. Please make sure you have the right ordering. So 1, 2, 3, and 4. Okay, if you have it in a different order, then it's going to be a bit of a mess later on. So sine A plus B, that's equation 1. Sine A minus B, equation 2. Cos A plus B, equation 3. Cos A minus B, equation 4. Okay, so what we're going to do is use the sum and difference of these equations to derive identities for these three types. So let's start with this first one, where we have sine and we have sine. Okay, so let's look at equation 3 and 4, where we have sine A sine B, they match up, and sine A sine B again, they match up. What we're going to do is take the difference of equation 3 and equation 4. We're going to subtract the two. Okay, so equation 3 minus equation 4. So on the left-hand side, again, we take the difference. And on the right-hand side, we take the difference. Cos A, cos B minus cos A, cos B, they cancel. We have minus sine A, sine B, minus sine A, sine B. That's going to double up. Okay, then we're going to take the minus 2 over to the other side, and we end up with sine A, sine B is equal to 1/2 cos A minus B minus cos A plus B. Yeah. Everyone see what we did there? So on the left there, we have a product of sine A, sine B. And then on the right, we have just two normal trig functions by themselves. So the product is now gone. Okay, please put a box around this first one. Okay, so this is what we're going to use for type 1. So please put a box around there and then put there type 1. Okay, so we're going to use that identity for the first type of integrals. Okay, the next type is where we have cos A, cos B. Okay, cos A, cos B. So again, let's look at our four equations. We want cos A, cos B by itself. So again, let's look at equations 3 and 4, but instead of subtracting them, let's add them. So we're going to have equation 3 plus equation 4. So we're going to have cos A plus B plus cos A minus B. Then cos AB, they're going to double up. And then the sine terms, they're going to cancel. Does everyone see that? Okay, so we add them. The sine terms will then cancel. So equation 3 plus equation 4. Okay, so the sine terms, they cancelled. Let's take the half over to the other side. So we have this equation now. Again, on the left side, it was a product. On the right side, it's just two simple cos functions. So this will be for our type 2. And please put a box around this one. Okay. And then the last one we need is for the third case, for sine A, cos B. So let's look at equations 1 and 2. What can we do with these two? Right, we want to cancel one of those terms there on the right. So what can we do? Just add them. Yeah, you can just add them. and then that term on the end there, that's just going to go. So equation 1 plus equation 2. So this will be sine A plus B plus sine A minus B. Okay, like we said, that's going to cancel, and we just have a double up of sine A cos B. Okay, then we take the half over, and we've got our last equation. Okay, so this will be for type 3, and put a box around that one. Okay, so please make sure you learn these 3. Okay, so remember for the class test 1 and 2 and the June test, that's open book. So you have all of the stuff with you. The final exam at the end of the year is not open book, so you won't have any of this with you. Okay, so for the first half of the year, you can refer to these, that's fine. The final exam, you don't have this with you anymore. Okay, so by that point, this should be memorized. Okay, I don't like memorizing things, but in this case, instead of re-deriving it every time, it's good to have it memorized. Okay, so let's do one example and then we can leave it for today. So example number 1, we have the integral of sine x cos 2x dx. Okay, now there's no powers or anything, so we can't use the stuff we did at the beginning. But what we do have is something like sine A and cos B. So in this case, it will be sine A, so A will be x, and cos B, so B will be 2x. So when we do the sum and the differences on that right there, it's going to be x plus 2x, x minus 2x. Okay, so again, we just write this as sine A cos B, and then we just identify what we need there. So this will be equal to 1/2. We can take that out to the front. So we have the sine of A plus B. So we said A was x and B was 2x, so we have to add them. So it'll be 3x plus sine A minus B. So that will be A is x, B is 2x, so it will be minus x. Okay, but sine is odd, so we can take the minus out. Okay, and this is very easy to do. So this is 1/2 integral of sine minus cos, and then the 3 comes out. So 1/3 cos 3x, and then integral of sine minus cos, so we get a plus cos. Okay. Everyone okay with this? All good? Okay. Now this is one way to solve this. We'll see as we go through with more examples tomorrow. There's going to be lots of ways of solving these problems. So this is one way. Now I'm going to show you a different way. You can pick whichever way you want. And then just a note for the class test. If you do it 2 different ways, you get the marks for both. Okay. So say I give you this problem for 5 marks. You show me this method, you get your 5. That's fine. Now, if you do this other method, well, now you get 10 out of 5. Or if you do a third method, now you get 15 out of 5, and so on. Okay, so for this class test 1, there will be a few problems. Okay, like I said, the 3 and the 2. But a lot of them you can do multiple ways. So the test is out of 30, let's say, you could end up with 50 out of 30. Whatever you get extra, that will be carried over to the next test. Okay, so I suggest you try to get as much as you can for the easy test, because when we get to the more difficult test, you want those extra marks. Everyone clear on that? Okay, so let's do it the other way. So I'm going to rewrite it the same. So sine x cos 2x dx. Now, what do we know about cos 2x? There's something, that's it, double angle. We can use that double angle formula. So this is going to be the integral of sine x. We can write this as cos squared minus sine squared, right? You know the double angle. You've seen this? Okay, you've seen it. Okay, so you put the double angle there, dx. Now this becomes the integral. I'm going to split it into two problems. I'll do the first one with you. The second one I'll leave for homework. So we're going to have cos squared and sine. We're going to write that here, cos squared x sine x dx minus the integral sine and sine squared. That's going to be sine cubed. Right. The first thing we did today was cos cubed, right? So for homework, please do the sine cubed. Okay, so the second one here, that's for homework. But this first one we're going to do, so we have cos squared and sine. If we let u be cos, what's du going to be? Minus sine. Okay, so we're going to let u be cos. So du, that will be minus sine. We don't have minus sign, so we take the minus over. Okay, so here we have minus integral u squared du. Okay, I'm not going to write the other part. You do that for homework. Okay, so this will be minus 1/3 u cubed plus whatever you get there for homework. And then we just put the cos back. Okay. So here, two different ways. So once you've done the homework, compare the two answers. You should get the same thing. Okay, so let's say this one's for 5 marks. Probably won't be 5, maybe 3, something like that. So let's say this one's for 5 marks. So now you do it this way, you got 5. Here's a completely separate way. You get another 5. Okay. And we'll look at more examples where you can do it two different ways like this. Okay. Maybe also for this one, maybe you want to try with integration by parts. Right? You know, it may not work out, but you know, you can try it out. Then that would be 3 ways. Okay, but for here, I showed you 2 ways. Does everyone get the idea on the different methods? Okay. Any questions about this one with the mixed ones like this? You're clear. Okay, so tomorrow we're going to do mixed problems. So for these ones, I said this power is even, this one's even, we do this one's even, this one's odd, we do this. Next, it's going to be mixed. Some you have to follow the rules, others you don't follow the rules, it will be all mixed up. That's what you should expect for the class test. Okay, so it won't be straightforward, you know, odd powers do this, even powers do this. It will be more like these ones, okay, where it's all mixed up. Okay, so that will be for tomorrow. Anything for now? You're clear? Okay, please start on the next tutorial in your free time. And then next week, Monday, we'll have the same thing, the tutorial assignments where you do the mixed problems in your group. And then we will have the quiz. So are you packing up? Do you want to hear what the quiz is about? Okay, please write this down. So the MCQ part will be figuring out which U substitution to do. So 10 marks U sub. So I will give you, let's say this problem here, integral cos cubed, and I will say U equals blank, right? You need to fill it in. So for this first one, the answer will be sine. for this next one, I'll give you the problem. I'll say u equals blank. The answer will be cos, and you fill it in. So there'll be 10 of those. And then for the written part, it will be a mix of questions. So maybe it will be one of these with sine and cos. Maybe it will be one of these with sec and tan. But I'm not going to tell you the powers and stuff. It will be a mix between those two. Okay. Maybe both powers are even. Maybe both powers are odd. It'll be something like that. It won't be these ones. Right. The one where we had to do other methods, it will not be that. It will be the ones where you follow these rules here. Yeah, just to cut down on your learning a bit. Okay. Any questions? All good. Okay, so that'll be it for today.